All right, welcome back. So we're going to talk about 11.3, which is partial derivatives. Actually, nothing crazy in this section at all. You guys will be happy to know that it really just is pretty much nothing different from what you learned in Calc 1. So let's just start by taking examples. And you'll see what I mean by that. So let's say we have f of xy equals x to the fourth, y to the ninth, plus 3x seventh, y. We could take the derivative of f with respect to x. So these little things, these partials, mean that we're just taking the derivative with respect to x, treating the y as constant. Okay, so the partial of f with respect to x is 4x cubed y to the ninth plus 21x to the sixth y. Takes just a little bit. You got to be a little bit careful. Okay. Let's take the partial of f with respect to y. Okay, partial of f with respect to y. We're going to take the derivative with respect to y, treat y as constant. Sorry, treat x as constant. Okay, so there, that's going to be what? 8 x to the fourth, y to the ninth. No, because I don't know why I said any of that. 9 x to the fourth, y to the eighth. Okay, plus 3x to the seventh. Let me move that 7 a little closer. There we go. Okay. All right. This also, you might see this listed, written as f sub x, and this is f sub y. Okay. Now let's go ahead and do second partials. Second partials are a little bit different. So one thing that we haven't really talked about it here, but these things together form what's called a gradient. Okay, so in some sense, the first derivative of f is actually a vector. Okay, the second derivative is actually going to be a matrix. The third derivative is a whole other thing called a tensor. We won't get into that. Okay, but let's take a look at the second derivative. The second derivative is actually going to be given, in this case, by 4 quantities. Okay. We're going to take fxx, which is the partial of f with respect to x, and then you take the partial of that with respect to x. So that means we're going to take the partial with respect to x, in this case, of this thing. Okay, so that equals what? 12x squared y to the ninth plus 6 times 21 is 126, last I remember. X to the fifth y. Okay, so that's fxx. Let's also take fxy. Fxy, now, it's a little bit tricky, okay, but you got to keep track of it. This is actually the partial with respect to y of the partial with respect to f of x. So that means we're going to take the partial with respect to y of this thing again. Okay. So that's going to be, partial with respect to y, it's going to be 36 x cubed y to the 8th plus 21x to the 6th. Okay, you got to be a little careful with it. Now let's take fyy and fyx. Fyy, that one's easy. Partial with respect to y of partial of f with respect to y, partial with respect to y of this thing here, okay, so that's going to equal, it's going to be equal what, 72 x to the 4th y to the 7th, and then this one doesn't have a derivative with respect to y, so that one we just got rid of. It's 0. Derivative of that with respect to y is 0. All right, finally, f sub yx. That's partial with respect to x, partial with respect to y of f, and that equals partial with respect to x of this thing up here again. Okay, partial with respect to x of this is equal to, let's see, 36x cubed y to the 8th plus 21x to the 6th. Now, what I want you to notice, this thing here and this thing here are the same. Okay, so for reasonable functions, for a lot of reasonable functions, large class of reasonable functions, those two things are going to be the same. Okay, that's Clairaut's theorem. Okay, let me state that before we go to the next video. So, okay, suppose f of xy is defined on a disk D containing the points A, comma, B. Okay. If both f of xy and f of yx are continuous in D, then f of xy AB equals f of yx AB. So what that means is that if you forget the order in which this goes, for most well-defined functions, it's not going to matter, okay? All you have to do, create, make it work and just stay consistent with the way you did it, and then these should be the same anyways, okay? All right, I'll see you in the next video.